the Army in the fields of research. And so that inspired me to get back here to Cancun, so I'm happy to have made it back. I connected with a couple of my colleagues in our South American office of aerospace research and development, Travis Tubbs and James Like, and they're going to follow on my overview of AFRL with some detailed presentations of how to actually work and get the collaborations in place. So before I get started into some of the details of AFRL, we are an organization made up mostly of scientists and engineers, but there's a host of other mission. And so I was able to receive a video that kind of gives a nice overview of AFRL and shows the many specialty areas beyond scientists and engineers that work in the lab. So with that.
Lead, discover, develop, deliver. The Air Force Research Laboratory leads the discovery, development, and delivery of warfighting technologies for our air, space, and cyber forces. Our scientists, researchers, and professionals reimagine what's possible, creating tomorrow's technology today. This pursuit of innovation delivers solutions for our warfighters' urgent needs, creating innovative new capabilities for the Air Force and Space Force. When others say it's impossible, we find a way. We are the Air Force Research Laboratory.
So as I said, pretty impressive video put on by our PR department. So not necessarily scientists and engineers, but really making it easy for us to get out here and explain some of these things to you. So a little background on AFRL. So we receive our demand signals for what research we do from both the Air Force Material Command and the Space Systems Command. So what we like to say in AFRL is we're one lab supporting two services, the Air Force and the Space Force in the US. And then we provide them with research that they can put into their operational activities. As you see, there's pretty broad coverage of our labs across the US area. We're in 10 states. I'll give a little more detail on the next slide on that. For us here in this Congress, I want to emphasize the global aspect of the Air Force Research Lab. So we have 5 locations throughout the globe that help to engage in collaborations with our partners throughout the world. So there's an office in London, England, that covers Europe, the Middle East, and Africa. There's a couple of offices in Tokyo and Australia that cover all of Oceania. And then we have the 2 representatives here from our South American offices, one in Santiago, Chile, and one in Sao Paulo, Brazil, that cover interactions with folks in Central and South America. So looking forward to hoping the organizers that are in this meeting from the symposia can spread the word, get the information out to start some collaborations or continue collaborations that we have across the world. Okay, so this is a little closer perspective on the ones that are in the US. I'll just highlight a couple of things. So the star there in the middle is our headquarters. That's where I come from. The location is Wright Pat Air Force Base in Dayton, Ohio. There's 5 labs that are also located there. There's another cluster of labs in New Mexico near Albuquerque. And then the other ones are spread kind of around the US. One other location I want to focus in on is the one in Arlington, Virginia. That's our Office of Scientific Research, Air Force Office of Scientific Research. They also hold the keys to the international office, so this is kind of their home as well. Our people are, probably our most important asset. I may have mentioned about 80% of our workforce is scientists and engineers. 80% of them hold advanced degrees, either MSEs or higher, and about 36 are PhD. But we also have a host of other business professionals, as I alluded to. One other thing I want to mention on this slide is that workforce development is something that AFRL is really focused on, especially during COVID. Getting the talent into the lab was a challenge. So we've stood up a couple of programs to help assist that. We have a number of hubs in the US that work with a group of academic universities to bring graduate and undergraduate students into the lab to work with us. It kind of gives them a flavor of the defense ecosystem, how we do our research. And usually that transitions into a summer work term. Our numbers in the labs grow in the summer with the summer interns. And then usually upon graduation, if they're interested, they'll get an offer, either full-time or contractor type position. So this is kind of the flavor of the research we do in the labs. Me being a researcher, I would have probably flipped this chart around and put basic research on the far left. That's kind of where I see things developing from. But this chart was made for our senior leadership, and they see the near term as a critical area. So it kind of also reflects the amount of funds. So the Air Force Research Lab executes the entire S&T budget for the Air Force. And about 80 to 90%, as you can see, is going to research in the applied or advanced or beyond, demonstration type phase. So only about 15% basic research, but it's still a fairly significant amount. And it can run up to maybe 20% if you put in a little of the applied. Last thing on this chart is to kind of educate you. So we work for the government, so we have a lot of acronyms. In the case of funding, you'll see the numbers under the research categories there. So 6.1, 6.2, 6.3. That's actually where the funding budget comes from. And so if you do collaborate with us, you might hear these kind of terms come across. These slides are going to be made available to you. So this is maybe a good reference so you understand our speak. Okay, so these are the technical directorates, the mission organizations in our AFRL. The first four on the left-hand side are the actual research laboratories. I'm going to go into a little detail of what each of those is focused on in a bit. The Air Force Office of Scientific Research there on the top right, that's the one I talked about in Arlington. They basically fund university academics, basic research, and it can be really fundamental, as the folks from our South American office will allude to, I'm sure. And then the next two, so there's been a big emphasis put on transitioning research to more applied and actual operational materials. And so these two directorates were stood up more recently to help make that transition over the valley of death to get your technology into an application area. And so they work with small business, industry partners, and even some non-traditional type contractors that we would not usually in the past have worked with. So it's been an evolution, and it's really showing benefit to date. So here's a little more detail onto those technical directorates. Like I said, AFOSR is the one on the top left. Materials and Manufacturing Directorate, that's where I've lived for the past 30 years. I'll give a couple more slides on that to give a little more detail, because I think that's probably the closest connection to this Materials Research Congress. And I wanted to have you get a little more information on that one specifically. But we cover structural, functional materials, and then we also support manufacturing technology. The Munitions Directorate on the bottom left, they cover all ordnance science, navigation for the ordnance, They have a big range down in Florida where they can do testing. I will say they're probably one of the harder ones to collaborate with just because of the classification stuff. But myself, I'm the senior international focal point for our directorate. All of the TD international focal points get together once a month. And my counterpart there in the munitions directorate, he still has quite a bit of international activity, so it's not out of the question. In the upper center, human performance, this is really dealing with like the physiology of the human subject when it's in a cockpit and what are the impacts, stresses that the body is feeling. So if you remember from the video, there was a centrifuge on there that's housed in this facility. They do quite a bit of subject testing, research, and then they also are involved in biotechnology and biology. Next in the center is our sensors directorate. They cover sensors across the whole electromagnetic spectrum. They also are looking at kind of identifying anything that's in the battle space. So that's the sensors directorate. They're also at Wright Pat Air Force Base. Center bottom is our directed energy directorate. They basically have two main missions. It's covering laser systems and high power microwave systems. So that's pretty short definition, but that covers, if anybody in here works with either of those systems, understands from concept all the way to demonstration of a system. It's quite a breadth of research, and materials are certainly a major aspect. On the upper right is the information directorate. They're in charge of our cybersecurity, command and communication research. Current focus areas are in quantum, neuromorphic computing, things of that nature. In the center right is the Space Vehicles Directorate. So they've been around long before Space Force was stood up. And they've historically done a lot of research in space materials for satellites and things of that nature, all the way from propulsion to navigation, timing, things of that nature. And then finally, the Aerospace Systems Director there in the bottom right. Basically, they cover propulsion, airframe design, turbine engines, rocket engines, all the way from concept to, again, to system development. This, I just have a couple of brief slides for the Materials and Manufacturing Directorate. Like I said, that's where I come from. So they cover the full spectrum of materials. So when I was looking at those symposium descriptions, there is something in every one of the symposium that would relate back to our directorate. So there's plenty of opportunity, I think, for us to collaborate. Again, the numbers on the bottom left basically mimic what I was saying about the numbers in the labs. Each directorate hosts about 1,000 employees. And then on the lower right is our kind of footprint in space for the labs. We're also dedicated to the digitization of the materials life cycle. So that goes all the way from developing autonomous artificial intelligence in researching materials. So we have an autonomous robot that can be used for any of our growth capabilities, from chemistry up to thin film growth using molecular beam epitaxy systems, where this artificial intelligence autonomous system can actually streamline the discovery process because it can work around the clock. It can be programmed to optimize a certain material property, let's say, and can repeat and make decisions on its own. So this is pretty unique in the digitization of the materials. Beyond that, it's more about making digital twins so that a lot of modeling can be done on these, even up to the level of one of our assets. So, and then the last slide, before I get off here, is basically a summary of those research areas we have in our directorate. Like I said, we'll provide these slides. These are contact people. You can certainly contact me or my colleagues here from South America, and we'll put you in touch with them. But these are kind of the big focus areas for our directorate. So I won't read them all just for the sake of time. And then this is my last slide. So if you want to read more about the Air Force Research Lab, that top QR code will get you there. And then if you want to contact us, the email QR code, and then there's more information on the other one for our partnering opportunities. So we do a lot of partnerships across all aspects of the material life cycle, and we're really happy to entertain international collaborations as well. So with that, I'm going to introduce Dr. James Like, and he's going to kind of give an overview of those South American offices and get into the details of how you would come to us for a collaboration. So if this doesn't work, you can just use that down arrow.
Okay, let's see. I got to get the. Okay, can everyone hear me? Okay, good. Hi, I'm James Like. Just call me Jim, and then Major Travis Tubbs, right behind me. Okay, we represent the Southern Office of Aerospace Research and Development, and I'm going to try to give us some context. Actually, a lot of things that John said I will probably cover just in a slightly different way, and I'm giving the message that we normally give when we visit campuses in Latin America. But we are here primarily to talk about the opportunities that we can provide for researchers in Latin America, in materials, but in many other areas. I think the benefits of the work, or one of the advantages, is that we can move pretty quickly. So we have the ability to establish grants fast, and we'll get into that. So the first thing, I guess, to understand is why would the Department of Defense in the U.S. make research investments in other countries? And I think the bottom line is it's the best idea. We know that since projects like the Manhattan Project, that we relied on the expertise of many foreign scientists. And so we started not long after the end of the Second World War to establish not only the idea of a basic research funding arm of the U.S. government, which became the National Science Foundation, we also established these offices within the Department of Defense, first in our own country and then in multiple locations overseas. So there's obviously a lot of benefits in doing that. And of course, the fact of the matter is that the Department of Defense, it's no secret that the U.S. DoD spends a lot of money in research and development. And I think John showed the different categories of research, and I'll mention those again. But there's the well-known organizations like DARPA, and of course each service branch has its own research arm. And John covered well what the Air Force Research Lab is. He also mentioned this sort of taxonomy of research, and I found that we needed to explain. Sometimes people in the campuses that we visit do not know what technology readiness level is, and I assume everyone here understands that nomenclature well. But the TRL levels from TRL 1 to TRL 9, of course, in basic research, we're more around the TRL 1. We often have to work with campuses where they're getting funding from oil, gas, or some applied activity, and sometimes it's actually hard to explain that we fund ideas that may not work, ideas that are radical, ideas that advance our knowledge. Shortly after the Second World War, Vannevar Bush and others erected what some people call the military-industrial complex, but when you're spending billions of dollars in research, it helps to organize what you're doing. And so this became the well-known 6.X nomenclature. And of course, I show basic research circled because that's what we focus on. But the Air Force Research Lab that John just talked about largely focuses on the next two areas, applied research, 6.2 and 6.3. So there's a lot more money going into the 6.2, 6.3. The basic research, though, the Air Force Office of Scientific Research controls all of the 6.1 investments of the U.S. Air Force and the Space Force, because as we have to remind ourselves, we newly erected a U.S. Space Force not too long ago. AFRL actually is the research arm for it as well. This is a very simplified diagram, but in it I try to start with the Department of Defense, and I walk down through some of the blocks that John was talking about to get to us. So first is the Air Force Research Lab, and you saw a different version of this chart. I won't review it again other than to once again emphasize that one of those technical directorates is the basic research arm called Air Force Office of Scientific Research. Now, if we drill down, so now I'm going into something a little different. As we drill down into what's going on in Arlington, we find that there are all these blocks that deal with specializations in research. Each of these blocks represents an individual who controls anywhere from 30 to, I've seen as high as 100 individual projects. Now, the blocks on the right are the international offices. And so, jumping down to us in SOARD, we're one of these several international offices that were created first in London, then Asia, and then South America. And we have two operating locations in South America. I work in the Sao Paulo, Brazil office. Major Tubbs works in the Santiago, Chile office. We manage projects not just in materials research, but a variety of areas. And in fact, we're a good reflection, and we are a remote projection. You could think of it that way. So I will often get a proposal in materials. I'll reach back to John for help. If I get a proposal in trust and influence, I'll work with a program manager. So we will try. And it's not to say that we're limiting our thinking to these areas which do cover a lot of ground. I mean, we see radical ideas all the time, and we do our best to try to find ways to support those concepts. Basic research is our quest, and I think herein lies one of the more difficult things to do, which is to define what basic research is. And there was this excellent book called Pasteur's Quadrant. I recommend it. It opens you up to think about where basic research begins or ends and applied research begins. And in fact, the short answer is that it isn't quite like that. There is a tight interaction between basic and applied, and often we go back and forth. And unfortunately, because we created that 6.1, 6.2, that very clean orthogonalization of our research, people think that that's the way it works in real life, but I think everyone here knows that it's more complicated than that. So we have to work with that complexity. And as we talk about how you work with us, part of what we do is to try to work with your proposal ideas to make sure that they pass the I guess the subjective sometimes test of what defines basic research. So I think what I'd like to do is turn over to Major Tubbs, and he's going to talk, I think, in a little more motivational way about what is basic research, why we care, what's different about what we do.
Thanks, Jim. Thank you, everyone, for taking the time to listen to what we have to offer. A couple things that I bring to the table is I was just like you. I was just a scientist at the Air Force Academy. I'm a Space Force officer, so I actually work for the Space Force. And I was a professor at the Air Force Academy doing my own thing. And some students came to me and said, hey, we've got this idea. And so I actually went through this entire process, and I reached out to the Air Force Office of Scientific Research and gave them a proposal. And my proposal was pretty simple. It was something just like this. As a matter of fact, this is what it was. And I said, we have an idea to put something some plants into space, and we got a little grant, a small grant, and that made it so we could actually make it a reality. And next week, this little box is getting launched out to space on the Polaris Dawn mission because of the Office of Scientific Research putting in their trust and their effort to try and help us expand our understanding of science. And so what I'm trying to say is that you can do the same thing. This is an opportunity that's open to everyone, but what we're looking for is the newest and greatest ideas, the ideas that are pushing those boundaries. And if we push those boundaries, then we can make them available to the rest of the world around us. Here's some examples of people who have pushed those boundaries, people that we understand. So for example, you can see right there, this is a biological study where they actually found that nature is using gears way before we as humans were using gears. So we're looking at these new ideas, new things that we didn't understand. We didn't know that gears were already part of a natural system. Looking at different mathematics, there's a whole bunch of different varieties of new innovative science that's out there. And this opportunity to push those boundaries is usually hard to find because there's not a lot of money in basic science. And that's where we come in to try and help this as an opportunity. So we're looking for the newest and greatest ideas that are innovative, something that's more along the reason of why are things the way they are? Why is it this way? And eventually we get to those points where we can say, okay, what can we do with that information? But we're asking the basic question of why. And how do we do this? We've got 3 mechanisms that we use. One, and probably our biggest one, is we have the opportunity to fund research projects. So just like this little box, we have these little projects that we can reach out and we can say, or you have an idea and we can take those project ideas, we'll read them and think of us in our office as your champions. We're here to take your science and see if we can't find people who would find interest in that at the AFOSR or AFRL levels, other scientists. If this is new and great science, we're there to help fight for your ideas, to help push it and make it as much of a new innovative process as we can. We take those ideas and then we present them to others and try and get some understanding between them. And if we can do that, we can make this a reality. We can actually give those grants to you. And it's a much better process to come through us to carry that water for you all the way to the top. Second, we fund conferences just like this so that you can come together and talk as friends and as colleagues so that we can come up with those new and great ideas. So that you can say, well, what are you doing over there? And I'm doing this over here. Maybe if we put those together, we can do something that's never been done before. That's why we support these conferences, to get you the opportunities to network and come up with the great science ideas that you have. And lastly, we have a program called Windows on Science, where we're actually able to send you to the United States to talk with some of our research leads, some of our AFRL folks, some of our AFOSR folks, to talk with them, work with them for about a week, where you can actually go up, see how they're doing things, explain what your ideas are, and get that interconnection with our team of scientists. Those are the mechanisms that we have funding for, so that we can offer that to you as scientists and as the new researchers that are pushing these ideas forward, to give you that chance to share your ideas with the rest of the world. And all we ask, and we'll talk about this, is all we ask in return is for you to make this available for everyone around.
Thanks. So, I mean, it's no secret we're looking for the Nobel laureates. We're looking for the best science we can find, and it's a win-win-win. Obviously, with basic research, because it's open academic, we're not doing classified work, so it's much easier, and for those reasons, we can move much more quickly to set up a project. I think in other circumstances, you can do international programs. They may take years before they actually can be begun because of those restrictions. We don't have that. Since 2009, we've had our offices first in Santiago and then in Sao Paulo. We've funded over 300 research projects, and this just gives you a rough idea of the demographics. Of course, the largest numbers in Brazil, And you can see the numbers there. There are numbers I want to do better in. For example, our reach into Colombia and Peru, I think we could do much better. I know there's excellent science there. But I think one of the arguments, or one of the existence proofs that we're doing that the offices serve a useful benefit is that really before 2009, we could have always worked with Latin America, but there were very few projects. And since we've been in place, we have done 300 projects. So there is something to be said about physical presence, us being in the region. I want to emphasize that what I say about the U.S. Air Force and Space Force is also true of our colleagues in the Navy and in the Army, and they have comparable budgets, comparable office structures. They have offices in Santiago, also in Sao Paulo. We work with them. We will share your ideas, usually with them, because by doing so, we have chances of funding more work. We funded 2 parts of the IMRC, or actually 1 part of IMRC in a conference before. Those were both co-funded by Navy and the Air Force. And there's a lot of other organizations that we've come into contact with, National Institutes of Health, USAID, other groups. And so we will try the best we can to find ways to support your projects. I think it's the best thing for everyone. The process for working with us starts with a simple white paper. And a white paper is just like an extended abstract. So on this white paper, you capture your ideas. You put the rough funding that you need, you break it out. Now typically a project in Latin America is going to be about normally $50,000 US per year for 3 years. That's the normal pattern. We have done shorter projects, we've done longer projects, but that's sort of that's the median. And this simple idea, at first I said, okay, well, great, it's like an abstract. What's the point? Well, there's several. One is you don't run to GrantsGov and start submitting, doing all the paperwork. You'll likely spend a lot of time, and a lot of times those proposals will never reach us. By doing the white paper, we have a chance to share that white paper with people such as Dan Miracle at Air Force Research Lab, other AFOSRV project officers, colleagues in the Navy and the Army. So it turns out this is a very powerful tool. We'll often go back and forth and reiterate on the white paper structure. But I mean, literally, if you're sitting here hearing what I'm saying, you could send me a white paper tonight. I mean, if you want to, and we will try to work with you. We try to keep track of anything that gets sent to us. And if you go through the smaller pain, I guess, of revising the white paper, work with us. We'll try to get that idea to something that really passes muster as far as basic research. Once we reach agreement on that white paper, then we will ask you to now go to GrantsGov and submit your proposal. At that point, you're more closer to 100% likelihood of getting that effort funded. And so this is the way that we have done since the office was stood up, and it's been, I think, the best way to get proposals developed. I think with that, I could spend more time, and I don't know if we're going to do question and answer, but I'll just leave you with one contact. We have, Travis and I have cards we can give you, but feel free to reach out to us, and we'll be happy to help you. Thanks for listening, and I don't know if there's another in the program, if we're going to have some additional speakers come up, or, okay.
And just the last thing is, we can't fund your idea if we don't have your idea. So it's going to stop there. So we need your ideas so that we can help fund them.
Thank you.
Do we want to ask questions?
Do you want to ask questions? Or are we good?
So the question's how much
How much is the budget to funding projects for institutions that are located in Mexico?
Okay. We don't actually divide the money that way. So I mean, I guess true to the mission of Best Science, we will accept. I mean, as you saw in the demographics, we funded about 50 projects in Mexico. So there's no minimum or maximum. If Mexico can come up with a whole bunch of Nobel-winning ideas, we will try to fund as many of them as we can. So there's no preset limit.
So on average, they're $50,000 for 3 years. That's
But
what it is
an individual
per project. And so if you have 10 projects from Mexico and they're all great ideas, we will try to fund all of those.
Okay, I'm sorry. I think
Your budget is it's military based, so it's way beyond the budget that any other agency can have.
No, if only that were the case. We all have our limitations, and of course we would like more budget than what we have. But the average is 50,000.
50,000. Okay, for 3 years.
Three years.
So a total of 150,000.
Yeah.
Oh, so 50,000 per year.
Per year.
Okay,
Correct.
good. Thank you.
Okay. Other questions?
Yeah, thank you for the presentation. Here, in the last actually.
The lights are bright.
So my question is actually, for example, if we have some patentable technology, for example, if I am going to release some kind of product, then how is our legalization? How between US, for example, and the universities in Mexico, we will talk, because who will stay with the rights and those kind of things?
So all the rights are yours. We don't take any of the rights.
Yeah. Okay.
We only ask one thing, and that's for you to make it public. So you can't
Right.
make something and keep it and say, I've got my own thing.
Right.
We want you to publish papers that are
Okay.
publicly accessible. We'll pay for the publishing even.
Right.
But we don't take any of the rights. They're all yours. We don't do any of that.
Okay, perfect. Thank you.
And we'll be available if anybody has any other questions or wants to talk with us.
Yeah, we don't have time for more questions. We have to go back to our rooms to continue with the Congress. So thank you very much for coming. Thank you very much for the work that you have done for many months previous to the Congress. And best wishes for this Congress in Cancun. Thank you very much.